Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. So today I have came up with another problem of assignment model and we are going to see how the Hungarian method works. So let us quickly move on to the questions. So this is the question where we have 4 persons and there are 4 jobs. So our objective is to find the minimum assignment cost. So we need to find the minimum assignment cost and we are going to solve this with the help of Hungarian method. Hungarian method, there are certain steps we need to follow in the Hungarian method. So we will see what we can do with this. So let us begin. So the first step in the Hungarian method says that prepare a square matrix. That means the cost coefficient matrix has to be a square matrix. So as we can see that it is already a 4 cross 4 matrix. It is already a square matrix. So the step 1 has already been satisfied, and moving on to the step 2, it says reduce the matrix. Now we are going to reduce the matrix with the help of row reduction and column reduction. Sorry. So reduce the matrix is done to get at least 1 0 in each row and in each column. So what we are going to do is we are going to select the minimum value in each row. So for the first row the minimum value is 5. So I have written here 5. Similarly in row 2 minimum value is 5. So this is 5. Row 3 minimum value is 4. So this is 4. Row 4 minimum value is 3. So now what we are going to do is we are going to subtract each element of this row by this minimum value 5. Similarly we'll do it for all the 4 rows. So let us see here. We have 5 minus 5 is 0. So this is 0. 7 minus 5 is 2. 11 minus 5 is 6. And 6 minus 5 is 1. Similarly for second row we have 8 minus 5 is 3. 5 minus 5 is 0. 9 minus 5 is 4. And 6 minus 5 is 1. For row 4, 4 minus 4 is 0. 7 minus 4 is 3. 10 minus 4 is 6. And 7 minus 4 is again 3. Moving on to row 4, 10 minus 3 is 7. 4 minus 3 is 1. 8 minus 3 is 5. And 3 minus 3 is 0. Now we are having zeros in each row and we also need to have zeros in each column. So as we can see here that after row reduction, column 1 has 2 zeros, column 2 has 1 0, column 3 has no 0. That means in order to get a 0 in this column we need to apply the column reduction method. Similarly here we can see the in column 4 we have 1 0. So for column reduction we will select the minimum value in each column. So for the first column minimum value is 0. For the second column minimum value is 0. For the third column minimum value is 4. And for the fourth column minimum value is 0. Now again we are going to subtract each element of this column by this minimum value. So let us see what matrix we get after applying column reduction. So 0 minus 0 is 0. 3 minus 0 is 3. 0 minus 0 is 0. And 7 minus 0 is 7. Similarly for second column 2 minus 0 is 2. And 0 minus 0 is 0. 3 minus 0 is 3. And 1 minus 0 is 1. Now for column 3 we have 6 minus 4 is 2. 4 minus 4 is 0. 6 minus 4 is 2, 5 minus 4 is 1. For column 4, 1 minus 0 is 1, again 1 minus 0 is 1, 3 minus 0 is 3, and 0 minus 0 is 0. Now after reducing the matrix, that is by applying column reduction and row reduction, we are having zeros in each row as well as in each column. Now moving on to the step 3, we need to make assignments. So how do we make assignments? We'll make assignment first row wise and then column wise. So what we need to do is, we need to go to row 1 and see if there is a single zero or not. If there is single zero, we will assign that particular zero, and if there is more than one zero, we will skip the row as it is and move on to the next row, and similar is the case with column. So let us start assigning. So we'll see row 1 has a single zero, that means this can be assigned, so I am assigning this. Okay, so row 1 has been assigned, that means no more assignment can be done in this row and no more assignment can be done in this column. So as we can see here, in this column there is 1 0 present. So now once this has been assigned, this 0 become ineligible to be assigned. Now moving on to the row 2, we have 2 zeros, that means more than 1 0. So we will skip this row and move on to row 3. In row 3 we have 1 0, but this 0 is not eligible for assignment because there is already one assignment in this column. So actually there is no assignable 0 present in this row. So we will skip this row and move on to the fourth row. In fourth row we see that there is one single 0, that means we can assign this. So I am assigning this. And now let us move column wise. So first column there is already an assignment. Moving on to column 2, we can see that in column 2 there is one single 0, that means I can assign this 0. So once I can assign this 0, that means no more assignment can be done in this column, and similarly no more assignment can be done in this row. But in this row we can see that there is another 0 present. So once this 0 has been assigned, this 0 becomes ineligible for assignment. Now moving on to column 3, we can see that there is one 0 present, but this 0 is now not eligible for assignment. So we will ignore this, and moving on to column 4, we can see that there is already one assignment. So we can see that in a 4 cross 4 matrix we have 3 assignments, and to get an optimal solution we need to have 4 assignments in a 4 cross 4 matrix. So this is not optimal. So what we need to do here next is, if the current solution is not optimal, move on to the step 4. So after making assignment we find out that our solution is not optimal. Now we need to move on to the step 4, which says that draw minimum number of lines crossing all the zeros. Now we need to draw a minimum number of line that will cross all the zeros in this matrix. Now there are certain steps we need to follow to draw minimum number of lines. So the first is tick all the unassigned row. So we can see that there is only one unassigned row. So we will tick the unassigned row. Okay, now if this ticked row has a 0, take the corresponding column. If a ticked row has a 0, then take the corresponding column. So this ticked row is having 0, so we are going to tick this column. Now in the next step, if the ticked column has an assignment, tick the corresponding row. So if this ticked column has an assignment, we can see that this ticked column has an assignment, then tick the corresponding row. Okay, then repeat the substeps B and C till no more ticking is possible. So we can see that after ticking there is no more 0 in this row, so our ticking has been done here. Now we need to draw lines through unticked rows and ticked column. So we need to draw lines through unticked rows. So row 2 and row 4 are unticked rows, so we need to draw lines from unticked row and ticked column So we can see here that all the zeros are crossed out with this minimum number of lines. So as we can see that we were having 3 assignment, and because of that we are able to draw only 3 lines. So once we reach the optimal solution, we will have all the 4 lines. We can draw all the 4 lines by this method. So right now, after drawing these lines, our next step is to create a new assignment matrix. Okay, now how do we create a new assignment matrix? So we need to identify the minimum number, let us say any number theta, identify the minimum number that have no lines passing through it. So we can see that in this matrix there are 3 types of cells. First is where no lines are passing. So here 2, 2, 1, 3, 2, 3. These are the cells where no lines are passing. And the second type is where only single line is passing. So as we can see, this cell, this cell, this cell, this cell, this and this. These are the cells where only single line is passing. And the third is where 2 lines are passing. So we can see that 3 and 7 are the values where 2 lines are passing. That means both lines are intersecting with each other. So 2 lines are passing. Now what we need to do here is we will select the minimum value among the cell where no lines is passing. So among these 6 cells the minimum value is 1. So we can say that value of theta here is 1. Now what we need to do, if a number of no lines passing through, if a number has no lines passing through it, that means for these cells where no lines are passing, we need to do Cij is equals to Cij minus theta. That means this is new Cij will be equal to old Cij minus theta. So we know that theta is 1. So now for this particular cell where no line is passing, 2 minus 1 is 1. So this has been reduced to 1. This is also 2. 2 minus 1 is 1. This is reduced to 1. This is 1 minus 1, 0. This has been reduced to 0. And similarly this 3 minus 1, that means 2. 2 minus 1, that means 1. And 3 minus 1, that means 2. Now moving on to the next category. If a number has 1 line passing through it, that means for the cell which are having only 1 line passing through it, for that the new Cij is equal to the older Cij. That means the values in these cells where a single line is passing will remain as it is. So this is 0, so it will remain 0. This is 0, it is remain 0. This is 0, it will remain 0. This is 1, so it will remain 1. Similarly here, this is 0, it will remain 0. This is 1, it will remain 1. This is 1, it will remain 1. This is 0, it will remain 0. Now there are 2 cells in which 2 lines are passing. So if a number has 2 lines passing through it, for that Cij, that is the new Cij, will be equal to old Cij plus theta. That means we are going to add this value where we are having 2 lines passing through any cell. So this is 3. 3 plus 1 is 4. So this will become 4. Similarly this is 7. 7 plus 1 is 8. So let us see again what we have done here. In this particular cell we have 3 types of cell. First is the cell in which no lines is passing, and we will subtract the value theta in these cells. and the second type is the cell where only single line is passing. So for those cell we will do nothing and we will write these values as it is. So we have written these values as it is. And the third type of cell where we have two lines passing through it. So there are two cells where we have two lines passing through it. For these cells we are going to add the value of theta in this cost coefficient. So this is 3 plus 1 is 4. Similarly this is 7 plus 1 is 8. Now after getting the new matrix, we need to again assign the values. So in this new matrix again we will do assignment. So we will do the same process, first row wise assignment, then column wise assignment. So for the first row we can see that there are 2 zeros, that means we need to skip this row. And coming on to the next row, row 2, we see that there are also here also we have 2 zeros, so we will again skip a row and moving on to the third row. In third row we can see that there is a single zero present, so we can assign this 0. So I am assigning this 0. Now this 0 is assigned, that means no more assignment can be done in this row and no more assignment can be done in this column. So in this column we can see that this is a 0 is present here. That means this 0 has now become ineligible for assignment because there is already an assignment in this particular column. Now moving on to the row 4, we can see that row 4 has a single 0, so we will assign this, and after assignment it says that no more assignment can be done in this row and no more assignment can be done in this column. So in this column we can see that there is 1 0 present. So once there is assignment, this 0 becomes ineligible for assignment. So after moving row wise, now we will see column wise. Moving on to column 1, we already have one assignment. Moving on to the column 2, we can see that we have 1 0 present in this column, so we can assign this. So let us assign this value, and after assignment we can see that no more assignment can be done in this column, and similarly no more assignment can be done in this row. So in this row we can see that there is another 0, but because this 0 has been assigned, so the other 0 becomes ineligible for assignment. Now moving on to column 3, there is 1 0 present, but this 0 is now ineligible for assignment. So we will skip this and we will move to column 4. In column 4 we already seen we had an assignment. So here also we can see that after assigning in the new matrix, we found that we are able to assign only 3 values. Okay, we are able to make only 3 assignments, which is not optimal. To get an optimal solution, we need to have 4 number of assignment because we are having 4 cross 4 matrix. So again what we will do here is we will draw the minimum number of lines crossing all the 0 just as we have done in the previous matrix. So let us see here. So to draw the minimum number of lines, it says that we need to follow certain steps. So the first step is that take the unassigned row. So this is the only unassigned row. Take the unassigned row. Now if this row has a 0, then take the corresponding column. So we can see that there are 2 zeros, so we will tick both the columns, 2 zeros. And now if this column has an assignment, take the corresponding row. So if this column is having an assignment, so we will take this. Similarly this column is having an assignment, so we will take this row. Now we need to draw lines through unticked rows and ticked column. So this is unticked row and ticked column. So this is ticked column. So again we can see here that for 3 number of assignments, the minimum lines we are able to draw is 3. So 3 number of lines we are able to draw. And now again the next step is to create a new assignment matrix. So in order to do so, again we will see that there are 3 types of cells in this particular matrix. First is where no lines is passing. So we will identify a minimum value theta from where we are having no lines passing. So among these values, 1 is minimum value, so theta is equal to 1. So theta is equal to 1 here. And the other type of cell is where only a single line is passing, and the third type is where 2 lines are passing. So what we need to do here is, if a number has no lines passing through it, then the new Cij is equal to old Cij minus of theta. So as we know that theta is 1, so this is 1 minus 1, so this will be 0. 1 minus 1 is 0. Similarly for this, 1 minus 1 is 0. Here 2 minus 1 is 1. Here 1 minus 1 is 0. 1 minus 1 is 0. 1 minus 1 is 0. And now for the cell having a single line passing through it, if a number has one line passing through it, for that the new Cij is equal to the older Cij. That means these values where a single line is passing will remain as it is. So we will write these values as it is: 0, 0, and this is also 0, 0, this is 0, this is 8, this is 2, this is 0. And now we need to see the cell where 2 lines are passing. So these are the 2 cells where 2 lines are passing. So if a number has 2 lines passing through it, then the new Cij will be equal to the older Cij plus theta. So we are going to add theta for these values. So this will become 4 plus 1, 5, and this will become 1 plus 1, 2. Now we are able to form a new matrix, and now we will try to assign here again as we have done in the previous 2 matrix. So let us see, we again will start with row wise assignment and then we will move column wise. So as we can see that for row 1 there is more than 1 zeros, so we will skip this row. Similarly row 2 is also having more than 1 zero, so we will skip row 2. Row 3 is also having more than 1 zero, so we will skip row 3, and row 4 is also having 4 assignments, so we will skip row 4. Now let us see if we can assign column wise or not. So for column 1 we are having more than 1 zero, so we will skip this column. Column 2 is having 3 zeros, again more than 1 zero, so we will skip this. Column 3 is having 4 zeros, so again we will skip this, and column 4 is also having 4 zeros, so again we need to skip this. So after this we can see that we are not able to make a single assignment because there are more than 1 zeros in each row and in each column. So in this case what we need to do here is, we can make any one arbitrary assignment and start assigning according to that. So let us assign this first cell arbitrarily. So I am assigning this, and because I have assigned this cell, that means no more assignment can be done in this row, and all the zeros in this row becomes ineligible for assignment. Similarly, once this has been assigned, no more assignment can be done in this column, so again this 0 also becomes ineligible for assignment. Now moving on to row 2. Row 2 we have 2 zeros, that means more than 1 zero, so we will skip this and move on to row 3. Now in row 3 we have 2 zeros but 1 zero is ineligible, so there is only one assignable 0 present here, so we can assign this 0, and once we assign this 0, we know that no more assignment can be made in this row and in this column. So after assigning this value, this 0 and this 0 becomes ineligible for assignment. Now moving on to row 4, we can see that there are 2 zeros, so we will skip this row. Now let us move column wise. So for column 1, we can see that there is already an assignment here. So let us move on to column 2. For column 2, we can see that there is more than 1 zero. Okay, so 2 zeros are here. So again we will skip this column and move on to column 3. In column 3, we can see that there is already been assignment. So we will move to column 4. So in column 4, we can see that there are 2 zeros, but 1 zero is ineligible and there is only one assignable zero present here. So because of this, we can assign this, and after assigning this, there can be no assignment in this column and in this row. So after assigning this 0 becomes ineligible for assignment. Now again, we have to see that if there is any possibility of assigning the values again. So again we will start row wise. Row 1 has already an assignment. Now moving on to row 2. In row 2, we can say that there are 2 zeros, but now 1 zero has become ineligible. That means that there is only one assignable zero present here. So we can assign this 0, and by assigning this, we can see that we are having all the 4 assignments, which is equal to the order of matrix. That means number of rows or number of columns. So this solution is an optimal solution for the value z equals to 0. So this is optimal solution for the value z equal to 0. Now what Hungarian method says that this optimal solution is optimal for this matrix also. We have seen in the previous lecture that how to solve this problem, learning the properties of an optimal solution. So we can see that this assignment is optimal for this matrix also. And now to find out the minimum value of z for this matrix. So the minimum value of z minimum for this matrix is equal to for the assignment on this matrix. That means the optimal assignment here is also optimal for here. The only value that changes is the value of objective function, that is the value of z. Now let us see that for this cell we have value here 5. So 5, this cell is having the value here 5. So 5 plus 5. Again this cell is having the value here 10. So this is plus 10, plus this cell is having the value 3. So we are having plus 3. So after assignment, the value here is coming as 23, and this is the minimum value of z we can obtain for this particular matrix, and we are having an optimal assignment as person 1 has been assigned to job 1. Similarly, person 2 has been assigned to job 2. Person 3 has been assigned to job 3. And person 4 has been assigned to job 4. So this is the optimal assignment, and this is the minimum value of z we can obtain for this particular problem. So I think it has been clear how the Hungarian method works. Let us again see what are the steps do we follow. First we need to reduce the matrix in the square matrix form, and then first we need to make the matrix a square matrix if it is not a square matrix. Then to reduce the matrix, we can reduce the matrix through row reduction or column reduction. Then we need to make an assignment, and after assignment we need to see if our solution is optimal or not. If our solution is optimal, then the value of z has been obtained, and if the solution is not optimal, we need to draw lines crossing all the zero, that is minimum number of lines crossing all the zero. And these are the methods we follow while finding the minimum number of lines crossing all zero. And after this we need to create a new assignment matrix, and again we will make assignment in the new assignment matrix and see if our solution is optimal or not. So I hope you like the lecture. If you like the lecture, please share the lecture. Have a nice day. Thank you.